In this video, we're going to focus on how we solve logarithmic equations. And this is kind of building on our last video in which we solved some exponential equations here. But essentially what I want to point out again is this. When you solve exponential or logarithmic equations, the first thing we always tend to check for is, can we use the one-to-one property of equality? Or that is to say, if it's exponential, if b to the x equals b to the y, then x equals y. Can we manipulate it so that both sides have the same basis to some exponent so that we could call the exponents equal? And likewise here, if the arguments are equal in these two logs, then they must have had the same basis, log base b of x and y. So x must equal y. So the first thing we're going to check for when we solve these over here, excuse me, is the one-to-one property. It's not going to work, just going to tell you right now, but we're going to check anyways. But essentially what we're going to do is we're going to isolate the logarithm and then rewrite it as an exponent here. So whereas we isolated the base of our exponential expressions and then rewrote it if necessary, in this case we're going to isolate the log. So let's write that down. Isolate the logarithm to solve this equation. And then our second step will be to rewrite exponentially. Okay? So now, that being said, let's take a look at this first example. We have the natural log of the square root of x minus 8 equaling 5. And so a few things that I want to do here. The first one is this. I'm not going to continue this pursuit here, but I am going to rewrite this as really what it is. We have log base e of x minus 8 is 5, and that's our natural log here. So that being said, what we want to do is isolate the log. Now, when I say isolate the log, I kind of mean that this log here is being taken of this square root of x minus 8. We don't have like a 2 in the front times this that we would have to divide both sides by. Or I don't have like, a plus 5 on the outside of this where I'd have to subtract 5 from both sides. But essentially, we have already isolated this log. So since we've kind of accomplished step 1 here, we're going to rewrite this exponentially. So to rewrite this exponentially, remember, we need to start by identifying the base. We'd say, well, then the base here is e. We say e to the power of something turned into this square root of x minus 8 thing. And so we say, well, what power did we raise it to? Well, it must be this 5 right here. So e to the 5th equals this. And you can see, I hope, instantly how we can just kind of now solve. I guess we could write that in. Oh, that's such an ugly 3. 3. Solve for x, or solve for the unknown. That sounds mysterious. So in this case, I noticed that we could use a square, square both sides, exponentiate both sides. So I'd have e to the 5th on the left. We're going to square that side, and I'm going to square this right side, and this should get rid of this radical for us. So now on the right side, we have this x minus 8. On the left side, because of our properties of exponents, we have e to the 10th power. So now our final expression here, adding 8 to both sides, just becomes e to the 10th plus 8. Now I got to tell you, this is a really big number, and just to prove it to you, because I know e is almost 3, and 3 to the 10th power would be big. So we'd say e to the power of 10, end parenthesis, we're going to add 8 to that. And we end up with this number right here, 22034. So we get approximately 22034 point. And I'll give you a decimal out of 3 places here, 466. So 466 units. But I would tell you that this is our exact value, and you'll want to make sure you list it first. This is our approximate value. So just to really emphasize it's approximate, I put an approximately equal to symbol, and I'm even going to write this. It's about that-ish. So now, this last expression, just like in our last video, we had one where we had to actually factor the expression first. It was kind of a special case where we couldn't isolate the base. We had to factor. This is also a special case, and I would say that it is a special case because the moment you try to isolate the log, you've got 2 logs. So one thing we could do is we could put this log on this side, and we could try to work 1-to-1. I mean, they're both base 2. But, just to show you what's going to happen here, if I put that log on the other side, I get 5 minus log base 2 of 3. And no matter how hard you try, you can't get this to drop out so that we can use the 1-to-1 property. It just never happens. So in an instance where you have more than one log, what we're going to do is condense the log. So this is a little note you might write here, but we're going to condense our log. And that essentially is what you see on this table over here saying use the properties of logarithms. So what I remember about the properties of logarithms are these. If we have log base b of x plus log base b of y, I'm just choosing letters here, but the bases are the same. We'd say this is a single log base b of the product of those 2 things that you see in these arguments here. And then likewise, we say log base b of x minus log base b of y would imply division is going on. So we say log base b of, and order matters here, x over y. And then our last property of logarithms, which was our power property, which we may need to use, so I'll write this again. N times log base b of x is the same thing as log base b of x to the n power. We can put that power back up on this thing. So we're going to use this property right here because what it's going to allow us to do is rewrite this as a single log, and then all of a sudden we've isolated the log. So now, looking at this, because they're both log base 2, we're going to rewrite this as a single log but base 2. And I would say, well, the two expressions in the argument of these are x and 3. We're going to multiply those. So I'm going to say x times 3, just to emphasize this. I mean, honestly, my whole self wants to write 3x in here, which I'm going to do now, but I wanted to show you what it is that I was doing. So now I'm looking at this. I don't have any coefficients out front of my log. I don't have any constants being added to or subtracted off from this log base 2 of 3x. So since I have the log isolated, we'll just rewrite this in exponential form. So we say, well, what's our base? Let's start with this. Our base is 2. So 2 to the power of something turns into this 3x thing. So 2 turns into 3x by taking it to the power of, well, of course, by the definition of logarithms, that guy. So again, we're going to get an exact value first. I'm going to divide both sides by 3. And so we get this. We get x equals 2 to the 5th over 3. I'm going to rewrite this again. That's 32 thirds, and I want these firsts. And then we'll go back and we'll get ourselves a decimal. So, 32 thirds. Just to show you, we could even do 2 to the power of 5 divided by 3. We do it in that order. We say 10.66 repeating. So I'm actually going to write equals because I can write a repeating symbol here. If I didn't write that and I wrote out to 3 decimal places, then I'd write approximately and the ish at the end of it. But that's how you solve a logarithmic equation. Cheers.